Welcome to a new video in my home automation OpenHAB and Node-Red playlist. In this episode I will be looking at this Eastron SDM120 single phase energy meter, and I will be showing how to set it up, how to set the basic settings of this device, and how to use it in OpenHAB and Node-Red. As usual, you will find the links to the sample codes and all the documentation I was able to find on this device in the video description. This video is probably going to be a little bit long, so I will put a description at the bottom of the screen now, so you can skip the sections on the video where I talk about the integration of Node-Red on OpenHAB, so you can skip the general introduction of this product. But first, let me start describing what this device is, the documentation I was able to find on it, and then let's see how it works in OpenHAB and Node-Red. So as you can see from the picture, it's a DIN rail mounted device. I think it's a single width, how it's called, and using this device is actually pretty simple. So at the bottom you have the live going in and going out, and on the top you have the neutral line. So this is how you connect it to your mains. So in my example I have this piece of lead which connects to my power strip, and the phase going out is powering these three sockets here. So I'm running my Raspberry Pi and the 24 power supply for some of my Modbus stuff, and one extra device off here, and it is continuously measuring all sorts of data regarding the power which is going through this device. It powers from the main line, so it doesn't require any external 24 volt supply. In terms of the outputs, on the top we have the two Modbus lines, the positive and the negative line, and in here at the bottom you also have some impulse outputs. So besides getting all the live data through Modbus, you can also configure the impulse output to give an impulse every, let's say, 0.1 or 0.01 kilowatt hours. In terms of the user interface, it has a single line LCD display with a single push button, and then you can cycle through the different screens. What I haven't mentioned so far, it's an import-export energy meter, so it measures energy going both directions. So at the moment I'm displaying power, this sum of kilowatt hours. So this is all the energy that goes through the device, and pushing the button I can display import, export, voltage, current, the wattage, this is frequency, power factor, and sorry, that's still power factor, and some other details. And now at last we see some of the Modbus details. So it is at the moment configured for ID30, and it is configured for speed 9600 bauds and no parity, and we are back on the first screen. I got my design from AliExpress, and unfortunately I don't have the link anymore, but if you just search on let me see, SDM120 energy meter, you can find quite a few listings online, and the price usually ranges from 22 to 24 US with free shipping, and probably there are a few variations of this product. As you can see, the graphics are slightly different, but hopefully we are talking about all the same. And already here you can see some of the main metrics. So it's 230 volt single phase 45 amp power meter with obviously RS485 Modbus interface and pulse output, which I mentioned before. Talking about the documents, I got two documents. There was this first document which was also printed and came with the device in the case or in the box, and you can see all the the metrics or the values the device measures. So it's kilowatt hours. So and always effective and reactive power, power factor, frequency, the voltage, etc. Well, we'll see within the Modbus all the actual registers that can be read, and it's bidirectional. So import and export, and 2 pulse outputs actually. And the Modbus features 45 amp rating. A bit more specifications here, and accuracy and operating operating environment. Again, just go into the video description and you will find a link to all these documents. And the pulse output features, so you can have it set every thousands, hundreds, tenth, or 1 kilowatt hours. And then you can even specify the pulse width. And the Modbus protocol, so it supports these speeds, so 1200, 2400, 4800, and 9600. So 9600 is the fastest, and by the way, the default is 2400. No parity and 8-bit, but we will see in this in the other document. And yep, the screen settings and the button, and you know how the screen looks like, you have already seen that, and that's it. Yeah, an important one is if you press the button for more than 3 seconds, this set will be displayed, and that's when you can start making the device settings. Quick schematics here, dimensions and the usual stuff. So this is the only thing which came with the document, and it's, as it says here, that if you need any more further details, well, actually the printed document said that I should email Eastron for the documentation, which I did, and within a day or so I got this second document, which is the Eastron SDM120 Modbus protocol version 2.1. And I'm just going to quickly flick through this. So it talks about the exception response and how you should format your Modbus request, which is, obviously is quite straightforward Modbus stuff. And of course, it also gives you examples how you query certain parameters. And I'm just going to skip all this because we'll see how this works in either Node-Red or OpenHAB. That's what is, I think it's a little bit more important. So it's the register map. So these are all the different registers we can read out in to get the various values. Some of them we have seen on the screen as well. Some of them are not shown on the screen. So now you can see obviously voltage, current, power, the active and apparent power and reactive power, power factor, and then the energies, both import, export, total, and all in active and reactive as well. So quite a few ones, and as you can see from the register addresses, they are spaced apart quite a bit. And I'm guessing the reason for that because the same register mapping is more or less used for a three-phase device. So if you think about voltage, so in a three-phase device you would have voltage 1, 2, 3, and those would be addresses 1, 3, and 5. So the next one, 7th, is the current. So current 1, 2, 3, and then you have power, active power 1, 2, 3, and so on. So that's why the reason they are spaced apart so much, especially the total energy is like address 343 and 345. And what is also mentioned somewhere in the document is they are using so every value is stored in 2 registers in a float value, float format. So you always read 2 registers. So for the voltage you start from register 1 and you read 2 registers. Fine. And next bit is this this other one, which stands for the that's responsible for all the configuration. So you can configure the relay pulse width, the network parity, the meterized, so that's the Modbus ID, the baud rate, and some of the other things like how fast it scrolls on the screen, so it can rotate the different readings on the screen, pulse outputs, measurement mode, and then that's it. So what I will be using here is I will set the meter ID and I will set the baud rate. And somewhere in this document, I think it says that the default settings is obviously, oh yes, the default is 1, the default speed is 2400, and no parity and 8 bits, and you can set the parity 1. And I'm not sure if it mentions that no parity is the default one. So that's all about the documentation, and first of all, let's see how we can change these two values, and well, what is the software that I use to make those changes. I plug my USB and serial converter to my laptop, so it's now appearing as COM2. And first of all, I'm going to go into this CES Modbus scanner just to see how I can communicate with the device. And because I've already set the change the baud rate and the station ID, I'm not going to use the default now. So I'm using COM2 9608, 8 data bits, 1 stop bits, no parity, and yeah, just leave the timeout. And the device is going to be, so I'm using station ID 30 for this device. And again, going back to the documentation, where is it? So we are using function code 4. Sorry, where is my thingy? Add request. Function code 4, which is the read input registers. I'm going to do offset 1 and length 2. And yep, okay, we can see the data coming through. The only thing is this this Modbus scanner cannot show the float value, or it doesn't show it properly for some reason. So all I can see that I mean, I can only see zeros or some really funny values coming back. But anyway, the communication is working. As you can see, we are sending data out, we are getting a response, we are getting this consistently, so we are definitely communicating with the device. And since all the values are coming through as float, I can't really pick another register which is going to get displayed correctly. So next we need to do the we need to use function 10 to set the holding parameters to set, for example, the meter ID. Unfortunately, this program it supports function, what is it again? Function 10. But the problem is that even the settings, as you can see the documentation here, the changing the settings are rather easy, because you set 0, 1, 2, 5 for speed, and for the device ID it's just a simple integer value. But even these settings are also stored in a float value, and we need to write 2 registers at the same time. Fortunately, if I use this one, it would write, I can specify length 2 here, and let's say value 20, which is the station ID, but it would mean that it will write value 20 into both registers. So I need to use something else, and that something else is going to be, let me close this one. So this something else is going to be Modbus Poll. You can download it from here, so modbustools.com. The only thing is that this is a paid program. It has a 30-day evaluation, meaning that you can download it and then you can use this to make the settings on the device, and then that's it. And obviously after 30 days you won't be able to use that. But to be honest, I'm only using this to set the address and the speed of the device, and that's pretty much it, because then after that I'm heading over to Node-Red anyway. So this is now Modbus Poll, and first of all I need to connect to the device. So I'm using this COM port or this device. These are the connection settings. Again, it will be 2400 by default, and I connect, and obviously it times out because I'm probably not using the right function to read the data. So going back to the documentation again, I should be using function 4, and the slave ID. So at the moment my device is set to 30 and I just want to read one value. Okay, and actually here I think I can set the formatting to float, or at least I should. Of course, I need to read 2 registers, and yeah, that's it. So float inverse. So this is the voltage that we see, 232 volt, 232.8 or anyway, 233 volts now. So now let's change the settings of the device. And again, I'm referring back to the documentation. So first of all, I would try to change the meter ID, which is register A0021. And in Modbus Q, what you can see is that we are currently connected and we are getting all the updates from the device. And if I look at the connection details, or sorry, if I the read-write definition, so I'm using slave 30 and I'm reading using function 4 to read the first 2 registers. So it's working fine. Now let's write registers. So for that I will be using function 16. And obviously this slave ID is 30. That's the current ID of the device. When you are using the unit out of box, that would be 1. And we want to write this register, but here in Modbus Q, the address is starts from the address indexing starts from 0. So actually we need to subtract 1, and all the holding parameters start with 40, so we don't need to use that in Modbus Q because the function 16 writes registers. So anyway, so 40021 becomes 20 as an address here, and we need to write quantity 2, and in the value we need to write the new address of the device. So I'm going to change the ID of this device to 60. And before we do that, we have to make sure that the unit is in the set mode. So I press and hold on the button for 3 seconds, and then the word set appears on the screen, and now I can send the command from here, and I should get a response. Okay. If you fail to change the mode to settings mode, you will get an illegal, I think it's illegal functions, it says. And what you can see here is that we are no longer receiving data from the device, obviously, because the device address has been changed. But if you go to the definition and you change the slave ID to 60, bang, it's online again. So we definitely managed to update the system settings, or the slave ID, the meter ID or the slave ID. And now it is the same with the speed. So for that, you would again use function 16, and now the slave ID is 60. The address is 40029, so that would be 28. Yeah, and let's say set it to 0. Edit value 0. Yeah, send, and we are still in setting mode. So if I'm sending, yeah, I'm getting the response, and the read function again timeouts. And if I disconnect, I go to the connection settings, change the data to that, and yeah, now it's working. So now we are reading data with obviously with a slow rate. So this is how you set the meter ID and the baud rate on this device, and using the same procedure you can change any of the other settings. So the network parity, the pause relay, so the pause width, and the output mode, and all this other stuff that you can see in the documentation. By the way, before you get confused, in the rest of the video I reset the settings back to station 30 and speed 9600. Before I start going into integration, I just want to go back to this list, the register map. And as I said, for this particular device, the registers are pretty much spaced out. And So if you're interested in voltage and also the total, let's say, active power or active energy, you would need to read like 345 registers at the same time, which could be a little bit slow on the serial bus. And it's not really my idea, but again, it was recommended to me in a forum that instead of doing one big Modbus read with all the all the possible registers, I should just have separate reads for the particular value that I'm interested in. And this is what I'm going to do. First thing I'm going to see is how this works in OpenHAB. And I have to say that I did this probably a few months ago, and since then I stopped using OpenHAB. So I have all the configuration file and actually have a screenshot on the on how it looks on the UI, but I don't have the I don't have it up and running anymore. So first thing to be done is head over to the OpenHAB configuration and start setting the Modbus device settings. And what you see here is pretty much this. And as I said, I'm going to do separate Modbus reads for every single value that I'm interested in. And I wanted to get the voltage, the current, the power, and the total energy out of the device. And as you can see, all these settings are going to be pretty much the same. So first is Modbus serial dot, and you need the ID of the settings, I guess. So obviously that would be different for every single parameter or every single register that you want to read out of the device. So I just named them SDM120 voltage or MDM120 current, SDM120 power, SDM120 energy. So for each of them we need a few parameters. The first is dot connection, which is equals /dev/tty USB 0, and then the connection settings. So again, here I use the default settings for the device, so 2400, which is the baud, and then colon the bits, so 8-bit, no parity, 1 stop bit, and we are using the RTU, so it's the binary Modbus protocol. The next one is it's going to be type input, so it reads the input registers, and the value type needs to be float 32, so that takes care of the conversion of the two registers into a float value. The length is always going to be 2 because we are reading 2 registers at the same time. So it's the main and the second register, and then the two together contain the value. And the ID is 1. Again, this is a default ID. I just set my device to ID 30 in the previous steps, so that would be the Modbus ID, and that's the start. So again, going back to the register map, you see the registers and they all start with 300 or 30,000. Again, here in the start parameter, we need the 0 indexed value of the register. So that's basically -1 of this one, and then just forget the leading 3. So the voltage becomes 0, the current becomes 6, the power becomes 12, and the total energy is 342. And that's what you can see here: start 6, start 12, and 332. And you would need to, if you want any more, any other settings out of the device, then just duplicate this group. And let's say you need the frequency, so just rename this SDM120 frequency, connection, input, value type, length, and the ID is all going to be the same. The only thing you need to update is the start, which, let's say for a frequency 30071 becomes 70 in the start parameter. So that's pretty much it. So next thing is to set up the items. And here, yeah, these are my items. So obviously they are all going to be numbers. So you give them the item name, you do the formatting. I do the voltage with 1 decimal, the current with 2 decimals, power with 1 decimal, and energy again with 2 decimals, and the corresponding units. And I just put them in the same group, SDM120, yeah. And the next one is the Modbus. So the source is Modbus equals, and then you specify the ID, which comes from the config file. So it's this one, or this one, sorry, or this one. And :0, which means that it's the zero, is the first register. So again, if you would set this length to, let's say 10, and maybe you can read, let's say, all the voltages and the currents and the powers together by reading up to 20 registers at the same time, and then here in the item config, so then you would have only one single of this group here in the config, and in the items you would say that, okay, voltage is index 0, current is index 6, and then power is index 12. So you can do it that way as well, which might work for the first few parameters, but energy being on 300 something is probably not the best way of overloading the serial bus bit, with such a huge amount of data. But again, if you are using low update rates and relatively high speed, that could work as well. Anyway, this is how I did it. So here in my example, it's always the ID, which is set in the config file, and :0. So it's pretty straightforward. And then when it comes to the sitemap, I just created a simple one. So I created a group, and within that group, I just use them as text items. And this is how it will look like at the end. So again, sorry, I don't have the system up and running anymore. So you will see the values, and they are getting updated based on the value which is here. So it's 500, so 500 milliseconds, so twice every second. And now let's see how the same thing works in Node-Red. So first of all, as you can see, I have already the flow created and it's up and running. And for that, I need to use a few additional components or nodes. And so the first one is the Node-Red contrib Nodebus. I'm using this one to read Nodebus data, but that's not the only one which can be used. And also that uses the Node-Red contrib serial Nodebus. So if you just if you go to the Node-Red flows and you type Modbus, you would be able to find, yeah, this node here, and then you find the installation instructions here, how to install it, and then some descriptions about how the this flow works. And of course there is a wiki page and a couple of fixed flow examples and a YouTube playlist as well from Klaus, who created this component or node. The logic I'm reading the value, it's pretty much the same what I did in Node-Red with in OpenHAB with probably just a few extra bit. So again, I'm using a different Modbus read boxes to read specific registers. So in this case, I'm reading the voltage, the current, the power, the frequency, and the energy. By the way, once you install the Modbus, you will see all these Modbus components here. So I'm using the Modbus read here, and I'm using the Q info also. You will see it later on. So when the data comes out of the Modbus, well, before we get there, let's go into configuration. So the first you need to set up is actually the server. So you come to the server, you would create a new Modbus client entry, and in here, physically what I have is I already have two devices on the same Modbus line, but it's physically the same Modbus line, so that I only need one server, which is my serial line, or that's my USB to RS485 converter, which is connected to the Raspberry Pi. So I give this a name. I select the type serial expert. The serial port is same what we have seen in OpenHAB, so it's /dev USB 0. By the way, if you click here, it will show you the available devices, which is quite nice. And I picked the RTU buffer, the obviously set the baud rate, the bits, the stop bits, and the parity, and what I have done is I've ticked the Q commands because what this Modbus component or Modbus node in Node-Red can do is, instead of sending the commands out whenever they are requested, it can actually queue the commands. And initially, I think there is a delay of 10. I've increased that to 30 because I had some issues with this energy meter working together with a temperature sensor, but probably I will come to that issue in another video. But regardless, you need to set up a Modbus server. You can choose whether you want to queue or not queue the commands. Probably you can play around which works best in your setup. I left all the other entries default, and I'll also leave the unit ID to default. You can specify the unit ID here, but since I'm using multiple units within the same serial line, I would not set it anything here. And on the actual Modbus read node, you specify the name. Here you specify the unit ID, you specify the function. Again, we are using 04 to read input registers. Again, refer back to the register map in the documents. And address is again the same format. So the address, the register address is a 0 indexed value. So 3001 becomes 0. And again, current would be 6, power would be 12, frequency 70, total active power, total active energy is 342. And just like before, we are always reading two quantities at the same time. I set the baud rate to 5 seconds, and I also tick these two ones to show the activities and show errors. And it's pretty much the same for all the other stuff. So it's the same concept what you have seen in the OpenHAB setup. So every Modbus node refers to the same server, same unit ID. The only thing which changes is the address. And as you can see, each of them wait for 5 seconds, and then one after the other they read the values from the energy meter. So the information which comes out of the unit, let me turn off these debugs. It looks like this. So you are actually seeing the raw data coming out of the device. So these are the values of the two registers. So we are getting two word values which need to be converted into float values, and that's what I'm doing in this function node. And you don't really have to understand how it works. I mean, honestly, I just copied this code from an example. But you need to specify the low and the high bit. So in the within the raw data coming out of the Modbus, the low is the second one, so it's payload 1, and the high, sorry, not bit but word, and the high one is this one, so it's payload 0, and then this does the conversion, and I am sending the converted float value back to the payload. And I'm doing this because again, you can read online that how this float value, what is the accuracy of it, and I'm just getting rid of some of the decimal places. So with this toFixed command, I'm converting the actual, let's say, for example, in this voltage to one decimal place, and with a parse float I'm converting back to float value, and I'm setting a topic, and you will see why the topic makes sense later on. And I also put out the topic and the payload into the node status. So even if I'm in the in the UI editor, or sorry, the editor, the admin page, I can see the actual values being returned by the device. Okay, great. And of course the individual values go to the UI element, so I just display the payload. And what I also do is I also build these values into a separate object, because if I want to use the the information coming out of the energy sensor, I don't want to see the voltage, current, and the energy separately. I want to see them sort of like grouped together. And in here, I just route or connect all these individual functions to this other function node, which basically builds an object together. So it just weights all these values and then puts them into an object. And there is a little bit of assumption here. So as far as I can see, Node-Red processes these nodes from top to bottom. So all of it would request the device to update the values every 5 seconds. But the way it appears to be working is that the voltage, current, power, frequency, energy, runs through in like sort of one cycle. So I know that when I'm getting an energy reading, I just completed a fresh or a complete update from the device. So so if I see that the topic is energy, that's the watch topic. So if I see if the topic is energy, then I actually return a message. But if it's not the energy, I'm not returning the message. So if I turn this debugging on here, I create the debug one, you can see that here I'm not getting a message every time any of these fires, but I'm only getting one message once the energy fires. So that was my way of reducing the data a little bit. And then as you can see, within the payload I have a nice object where I have the voltage, current, power, frequency and energy in one single object. So it would probably be easier to use. By the way, let me turn on a light so we can see that actually some of these readings go up. Okay, yeah, we have 8.7 watts. You have to know that this device doesn't work well with really low currents, so I think it needs to be at least like probably 200 milliamps for the device to show. Otherwise it just shows zero current. If I would connect a hairdryer, it would obviously go up. Oh, okay, now we have 100 milliamps and the power is 10 watts. Okay, great. And the rest of the code here, I'm going to include this, but it's more about, some sanity checks. Like I have this information, so maybe I can, also see if there is anything wrong with the voltage. So I've just put some checks to give me a warning if the voltage goes below 220 or goes above 250. I mean, ideally it shouldn't really happen. I'm connected to a grid, but again, it's just like, yeah, if I'm sending out some diagnostic messages which I'm saving in the system later on. Again, I haven't covered this part in a video, but I will do it in the future. But for you starting to use the this energy meter, I think this is that's probably the last object that or the last part of the flow that you want to use. And then this function should give you this nice object as an output every time there is like a full update from the device. And this is why it is important to also have to set the topic for every single messages which are coming, which are leaving these individual function nodes. So in here, where I know that I'm actually getting a voltage or a current or a power, not just just a random value. The other thing I'm doing is it's again based on the YouTube videos from Klaus, how he's managing or monitoring the Modbus device itself. The first one is the queue. So because these these Modbus reads are queued, or the entire serial line is queued, you can have this Modbus Q info node, which is down here, and set it to a particular unit, and then have some thresholds. And first of all, what you get, I think you need to, oh no, nothing. First of all, what you get is that you get an update here as well to show how many items you have in the queue. So obviously, if it starts building up, then it might indicate that there is an issue with your device. Like if it's, if it's not processing the requests and it's not returning responses to the server, then this queue number would go up, and you can see that it goes up, but it quickly goes down to 0 as we are getting response from the unit. And there is a possibility to reset the queue. So if you send a message.request queue, reset queue to true, then you can reset the queue. So I can do it with this timestamp. And also what is possible, and what Klaus recommends, is you create a catch node, and I put this catch node on the queue itself. So that's the queue. And if this queue reaches this high level, so if I have like 300 messages in the queue, then this node will create an exception, and this exception will be catched by this catch node, and it is also going to create a queue reset, set to true. So I feed it in here, it's going to reset the queue, and again it's going to leave me a diagnostic message saying that something has gone wrong, because I have 300 messages in the in my SDM120 queue. So probably the Modbus device is down, or is not responding for whatever reason. And I've also created another catch which is looking at all the Modbus reads, and if there is any exception happening there, then I will catch that, and I also save that as a message for myself. So that would be most the basic monitoring that I do on my Modbus, just to make sure that it's it's running healthy and I'm getting the messages as I expect from my energy meter. Actually, there is actually one more, is this health check. So again, I've connected this to one of the Modbus reads, and what I am doing here is it's quite a bit of a code, but it's quite simple. What I'm doing here is I'm creating this context value, which is the device name, which is SDM120. So I store it as a constant here. So I do I get the device name underscore update, which I expect to be a timestamp value. And so this function has two inputs. So it gets a message every time there is an update from the energy meter, and then it also gets an update from this inject node every single second. And the topic of this inject node is time check. So if the topic is not time check, which means that the message is coming from Modbus, I save the current timestamp in the context in the same update one. So every time I'm getting a message from the Modbus, I'm setting the timestamp for it. And yeah, of course, it's nothing because it's running for the first time. I'm also setting the current timestamp. And basically what I'm doing here is I'm calculating the time between the store value and between what is the current time now. And that's why I'm getting, last update was 1, 2, 3, 4. Sometimes you see a 5 as well, but it quickly resets as the data is coming back from Modbus. So I can tell what was the last time I got an update from the Modbus. And what the rest of the code does is basically just says that, okay, if this current, which is now, it's instead of showing the current time, but it shows the seconds elapsed between the, because it says current minus temp. So now here the current shows me the number of seconds passed since the last update. So if it's below a threshold, so let's say if it's below 10, if it's below 10 seconds, then I can see that, okay, my unit is online and it's working, and I'm saving this. First of all, I'm saving this in the context, and I'm sending some data out to my diagnostic system. And if the current is above a threshold, so let's say if I haven't received any message from 30 seconds, then I'm saying that, oh, something is wrong because my energy meter is not transmitting. So the USB converter could be disconnected. The device might be offline for whatever reason, or there is an issue within the Modbus line. And yeah, just finally I update the node status to show me these updates. So again, it's really up to you how you want to monitor your Modbus device, but if you want to make sure that things are running smoothly, maybe this is a good way to have a sanity check on how frequently you are getting update from the device and what is it, how does it looks like versus your expectations. But I think that would be pretty much it. Actually, I probably need to show the UI as well. It's not awfully complicated. So far I just dumped the values on the UI. I've created a new group which is called the Modbus, and right now it is monitoring two devices. It's one wire and Modbus. So I'm getting all my energy meters, energy readings here, and I also have a temperature sensor which I've covered in a previous video. And if I turn the lamp on, this power probably should jump back to 0. Yeah, it jumps back to 0. But in fact, it's not 0, but it's the power being consumed by the Raspberry Pi adapter and a 24-volt power supply, which is powering the temperature sensor. So it is, well, actually, okay, it's 4.2 watts. So the reason it is jumping up and down because there is also a phone charger connected to it, but the phone is already at 100%, so probably it draws some power and then it turns the charger off. Just the reason I'm highlighting this, because if you are using really small power, then in most cases you were getting 0 watts and 0 current, but regardless, the total energy will definitely count up because it is going up steadily, but really slowly because there is not a huge consumption here. So I think that would be pretty much it about my SDM120 energy meter and how to use it, well, mostly under Node-Red. I don't think my Modbus setup is probably complete, so I might be having a separate video on using Modbus in Node-Red with multiple devices and some of the caveats and let's say error handling and monitoring of it. But that would be all for now. I hope you find it useful, and see you in the next video. Bye bye.